So in the last class, we began discussing arrays. And so, like I said, an array is a contiguous space of memory in the RAM, contiguous sequence of cells in the RAM, where you can store some series of values. And this array will have relative addresses and also absolute addresses. Relative addresses are nothing but relative positions. It starts from 0 and goes up to n-1 if the array has n elements. So the indexing starts from 0, not 1. It doesn't go from 1 to n. It goes from 0 to n-1. We will see the reason why when we get to pointers. But right now, remember this point that it starts from 0 and goes up to n-1. This is fixed. This can't be changed. It's not optional. And absolute addressing, there is some absolute location where this array starts in the RAM. That we don't know. We can know if you want to print, we can print that value, but usually we don't deal with that. Fine. And so we just took examples of integer arrays. So there are different ways of declaring and initializing. Like I said, there are two steps in any variables, any data types, primitive data types or derived data types. You have declaration as well as initialization. You can combine them or you can separate them. In arrays also, you can combine them or you can separate them. If you separate them, it will look somewhat like this. Okay, here declaration is done in the first line. The initialization is done separately. If you know the values, you initialize each cell with its value later. If you know all the values beforehand, okay, you can combine both of them in the same line, declaration as well as initialization. In declaration, what all you need? The array data type, the array name, and also the array size, right? In normal variables, primitive data types, you only need the data type and the variable name. Here, you need an additional thing, which is the size of the array. Okay, so size of the array, either you can specify manually or you can get from the values. In case you know the number of values and the actual values beforehand, then you need not specify the array size beforehand. This array size will be sort of inferred from the values you are providing and the number of values you are providing. So here array size, specifying array size is optional in case you know the values already. But if you don't know the values already, okay, then you cannot leave it like this. You cannot just say array name and data type and empty brackets. That will not work. So either you give the values and put empty brackets, or you don't give the values and put a value. You put the size. You don't give the values of the array, but put the size of the array. Okay, one of these needs to be done. And you can always specify an array of larger size and give fewer elements, where the number of the remaining elements will be initialized to 0 by default. Okay, so we saw some codes related to this in the last class, so I won't get into that again. So these are some points which I just mentioned. Another thing, when you see A of 4 in this case, like in the previous example here, this A of 4 is visible only in the first line, that is the declaration line. So here 4 in A of 4 is telling the array size. All right. In all the other lines, apart from the declaration line, whenever you see A of some number, that number refers to the position of the elements. So that position index, it's basically the index. That index goes from 0 to 3 for this example, 0 to n-1. So you will never see A of 4 anywhere here. Okay, so when you see A of n, there in the declaration line, n refers to the size of the array. In all the other cases, A of some number, that number refers to the position or the value of that particular index. So you will never see A of n elsewhere because it stops at n-1. The indexing stops at n-1. So you will always see A of 0 to A of n-1 values only, anywhere else. Okay, so declaration line is the only place where you will see A of n. All right, so this is something to keep in mind. And second thing, again, this I said, array index always starts with 0 and ends with n-1 for an array of size n. Okay, and you can access the elements using A of 0 to A of n-1. And if you try to access elements greater than n-1 index, it might print 0 or some garbage value. This also we saw. Okay, you can go beyond the array limits. You can say, suppose here array was A of 4. Now suppose I want to print A of 5, A of 10, A of 100. It will not raise any error. It will access that memory location and print its value, which is technically possible, but security wise, it's a bad thing. you are allowed to access out of bounds memory location, which is not a good thing. But that is a problem with C. Other programming languages try to prevent that using some mechanisms. But in C, it is possible, but it is not a good thing. Still, you can do it. You can go beyond the array bounds and you can access some memory location outside the array as well. But it will print some garbage values. We don't know what values are there. We don't know which program is using it. We don't know. But it will just print whatever value is there in that cell. That's all. And an array can have elements of the same data type only. This also I mentioned. An array is a homogeneous derived data type. Struct, which we will see later, is a heterogeneous derived data type, which can be a combination of integers, floats, characters, and so on. But array is always having same kind of values. Either it is a sequence of integers, or it is a sequence of characters, or it is a sequence of floats, and so on. It cannot be a mix. It should be of same type only. Okay. So these are some different examples. Although here all the examples in this particular slide are related to integer arrays, same thing can be done with any other data type. Float, double, char, same thing can be done. So we can create integer array, float array, double array, char array, long int, all whatever primitive data types you learned, all the different combinations, you can create an array for each of those combinations. Okay. Out of these, character array is slightly special because a character array is what we usually call a string. In other programming languages like Python, etc., you have strings. Like you have many functions which you can perform on strings. Like you can concatenate two strings, or you can search for a substring within a larger string, or you can copy one string to another. You can find the length of a string. All these things, we do many things with strings, right? Like we suppose we have a dictionary of words. We sort that dictionary. So it's like sorting strings, right? So many things we do with strings. So string is slightly special, and it is easier to deal with strings as strings rather than as sequence of separate characters, right? It is technically a sequence of characters. That's all. It's an array of characters. That's it. So in that sense, it is no different from any other array. But it is slightly special because we deal with strings, each string as one unit. But when you have an array of numbers, they can be random numbers. You don't deal with all those arrays as one unit. You deal with that array as one unit to some extent, but semantically they don't have a meaning. But when you have a string, that string as a unit may have a meaning. It may be a word, it may be a name, it may be an address, whatever it is. So they have a meaning, right? So we deal with strings many times. So strings are slightly special among all the arrays. So character arrays are slightly special because we use them many times for different purposes. So there are some additional functions given to strings, and we can do to make our life easier for character arrays. Okay, so these are examples of strings. So a string is nothing but a sequence or an array of characters. It's an array of characters. Okay, but no other array has a separate name. Array of integers doesn't have a separate name. Array of floats doesn't have a separate name. But array of characters has a name called string. Okay, always enclosed in double quotes. A string should be enclosed in double quotes. A character should be enclosed in single quotes. That's a distinguishing factor between double quotes and single quotes. So these are some strings. Hello, hello world, and even a number. When you enclose in double quotes, it becomes a string. It's not a number anymore. Okay, so it is treated as a string. You can't divide this thing with some other number. It's a string. It will give an error. It's like it will tell you are trying to divide a string with a number. So that is not allowed. When you put anything in double quotes, yeah. Yeah, so when you put it like this, it will take it as an array with 3 characters, which means 3 bytes. It will, if you write 234 without quotes, when you say int x equal to 234, then it will give 4 bytes. Yeah, good question. So the data type changes. All right, and this is also a string. And even if a single character, if you put in double quotes, it becomes a string. Okay. And this is also a string. So how many characters are there in this? 7. Even this decimal point is a character. Okay, so there are 7 characters in this string. Fine. So you should always be clear what data type you're dealing with. Just because you see a digit doesn't make it always a number. It can be a character, it can be a string. All those things matter. That is why you should not be confused between ASCII values and the digits. When you put a digit in single quotes, that digit has a different ASCII value. So this digit is not stored as that number. This digit is converted to its ASCII value, and that number is stored in place of this digit. Like when I input 0 as a character, its ASCII value 48 is stored. Okay, 0 is not stored. If I want to store 0 itself, and if I want to treat it as a character, then the corresponding character is the null character, not 0. Okay, so 0 when treated as a number corresponds to a character called null character, but 0 when treated as a character will have an ASCII value called 48. So you need to be clear whether you're dealing with character or number. Okay, anything not enclosed in double quotes is not a string, right? Like A, if it is in single quotes, it's a character, it's not a string. Hello, if it is in double, if this entire string is in single quotes, it's not treated as a string. It will give an error because single quotes can be used only for characters. You can't use them around strings. That will not be accepted. So that's an error. And 234, no quotes. So it's an integer. This decimal number, no quotes. So it is a float. Okay. The last character of a string is always a null character. We will see why this is. Hence, the string length should always be n+1, where n refers to the number of visible characters. Okay. So before I give you examples of the syntax of string, so let's take an example. So one way of storing, declaring array, integer array. Let's say if I have integer array, suppose I say a of 4. I have say 4 numbers, 4, 8, minus 5, 12. This is one way of declaring integer array. Here I am combining declaration as well as initialization. Another way is I declare it, and then this initialization will not work. If you are separating declaration and initialization, then you cannot do this anymore. This will not work. You have to take element by element. You should say a of 0 is 4, a of 1 is 8, and so on. A of 2 is -5, a of 3 is 12. Either you do that or you scan each element from the user. Scan a of 0 from the user, scan a of 1 from the user, and so on. Either you write separate scanf statements or you put them in a loop. For I equal to 0 to 3, scan a of I from the user. That is another way. Okay. Now, similarly, if I want to declare a character array, one way is, suppose I say H E hello. Suppose I want to store hello. I am storing character by character, right? I need to put each character in single quotes so that it knows I am storing a character, not a number, right? And say I close it here. All right. Now suppose I want to print it. 4, right? I'll say 5 because I am storing 5 characters. All right. Now suppose I want to print it. How do you print an array of integers? You run a loop for I equal to 0 to, in this case 0 to, it stops at 5 or 4. 4, 0 to n-1. Array size is n. Index goes from 0 to n-1. So in this case, I goes from 0 to 4. Print a of I. Okay. So for int I equal to 0. If you don't put int here, what will happen? It will give an error because I is not declared. Okay. I less than 5, which means I stops at 4. I plus plus, I'll print the character in this array. Say I'll print each one in a new line, a of I. Okay, fine. Printed. All right. Now same thing, I can print without a new line, so it will print it like a string. It looks like a string. You see, now it looks like a string. So I'll put a new line here. It looks like a string. Actually, what is it doing? It is printing each character one at a time. It's an array of characters. That's all. Now, to make our job slightly easier, instead of going through a loop to print each character by character, there is a special format specifier for an array of characters. There is no format specifier for any other array. Only for array of characters, there is a separate format specifier. So can anyone tell me what that is? Percentages. Percentages. And in this case, what should I give here? Just A, because I'm printing the entire string. I'm not printing one character at a time. I'm printing the entire string. So all I need to do is give the array name. Okay. And then you print a new line. It will anyway print that. Okay. Fine. This is fine. All right. Now, in this case, I have 5 characters and the array is full. All right. But there can be cases where now, okay, let me copy this. I will put a special character and then I will put 2 more characters. Okay. And I will say array size is say 7. No, 8, right? Technically, array size is 8, right? Or I will even remove this. Now, what is the array size? How many characters I gave? 8. So array size will be 8. Okay. Either you specify 8 or it will take 8 automatically. Fine. Now, when I say printf percentages, any guesses what it will print? Any guesses what it will print? I can show it. What will it print? Hello, MR. Some random character and then MR. Okay, let's see what it will print. It just printed hello. Okay, why? Because this \0 is called the null character, and this null character acts as a delimiter or a terminator or a marker that ends the string. Okay, so when you say percentages, you didn't tell how many characters to read. You see, when you are using the loop to print character by character, you need to specify where to stop. You need to specify how many characters to print, how many indices to go through. But when you are using percentages, you're not telling how many indices to go through. The string may be smaller than the array size, larger than the array size, or equal to the array size. It can be anything. So how does it know where to start and where to stop? It doesn't know how many characters it should read or it should print. So the only way is there should be a delimiter or a marker which tells it when the string ends. Okay, so that delimiter is called the null character. So the moment it sees the null character, it assumes the string is over. Whatever is there after that, it doesn't care. Okay, so when you are using percentages, it does not look for the number of letters. It doesn't know the number of letters. It looks for the delimiter, that is null character. Okay, so null character is necessary for strings because you can use percentages only with strings. So null character is necessary only for strings, not for other arrays. Only for character arrays, null character is essential. So whenever you are declaring a character array, always give one extra space for the null character. So if your visible characters are 5, declare an array of size 6. Okay, to store the null character in the 6th position, so that whether you loop through it or whether you use percentages, it will print the entire string. It will stop at null character. It will print all the visible characters before that. Got it? Okay. That is why this line, the last character of a string that is invisible to us is always a null character. Okay. Hence, the string length should always be n+1, where n refers to the number of visible characters. So it looks like this. So these are different methods in which you can initialize a string. So this is one method. I didn't mention this method to you, but I showed this method to you just now, right? You give character by character. I didn't show this null character, but if you are giving character by character, you need to specify this null character. So make the array size 6. If you have 5 characters in your string, make the array size 6 and store the null character as the 6th character. Okay. Why? Because if you want to use percentages later, this null character should be there. If you are using loop only, then this null character doesn't matter. If you are going number of cells at a time, and if you know the starting cell and the ending cell, then null character doesn't matter. But if you want to use percentages, you're not using loop. You're not telling what is the starting index, what is the last index. How does the computer know? It doesn't know the index. So it will go until it finds the null character. So it will go even beyond the array bounds. Okay. So it will look for the null character. If you want to use percentages, you should ensure that it has null character. Fine. Or other way is, you don't want to give one character at a time, H, E, L, L, O, so much you don't want to type. You want to store the string hello, then specify like this. In this case, you need not worry about the null character. It will automatically insert it. But you give the array size as 6. Because you know null character will be inserted later, so space should be there for that. Okay. So in the double quotes, you put only the visible string. You don't worry about the null character. It will break this, it will break the string into characters, into 5 characters, and it will store each of these 5 characters and insert a null character at the end. So 6 characters will be stored in the array. So you give the array size as 6. Okay. Another way is like how you do for integers. You declare, here declaration is separate, initialization is separate. In both these cases, declaration and initialization are done in the same step. Okay. Even in this case, declaration and initialization are done in the same step. And since initialization is also done in the same step, here giving the array size is optional. Either you give it or you don't give it. Suppose you want the array size to be exactly as much as the string you are giving, then you need not even specify the size. But suppose you know the array size is larger than the string which you are giving, then you better give the array size, because your array may store up to 20 characters or 100 characters. Then you give the array size as 100. So that in case you are increasing the string later, there should be space for that. Okay. But if the array size is exactly equal to the immediate string, it's optional. You count the number of characters in the string and specify that number, or you don't even specify any number, it will automatically take that number. It will itself count the characters and give that number to the array. Okay. In this case, you are separating declaration and initialization. Okay. In this case, you have to give each index value separately. Okay. So this is what I said. Your array size, suppose you know my maximum string length is 20, then you give that. Your initial string may be smaller than that. That's okay. But your maximum string length is 20. So it's better you give 20. Okay. Don't give empty brackets. If you give empty brackets, it will just take 6. But you want to store strings of length up to 20, then you shouldn't give empty brackets, right? Even in this case, maximum string length is 20, but right now I have only 5 characters ending with a null character. Okay. All the remaining characters will be initialized to null character as well. You see, this is exactly what is happening even in integers. What did I say? Suppose you are giving only 4 values when you're initializing, but suppose your array size is 20. What will happen? All the remaining 16 values will be initialized to 0, right? That 0 is an integer. That integer will be stored as integer itself. And that integer will be the ASCII value of what character? Null character. So even in this case, what is happening is it is storing zeros in the remaining places. Those zeros are nothing but null characters. So you can say the same thing in both ways. In the remaining places, it is filling with zeros or it is filling with null characters. In both the cases, it is doing the same thing. Since we are discussing character array, I am speaking of what are the remaining default characters. That is a null character. And when I'm discussing integer array, what are the default values, remaining values? What are they filled by default? What are they filled with? That is 0, because I'm discussing integers. But both are same. The zeros there and the null character here are same, because 0 there is the ASCII value of the null character here. So it is not like for an integer array, it is using a different number. For a character array, it's using a different number. it is using the same number, that is 0 itself. When you treat it as a character, it becomes null character. That's all. Okay. Now, this will not work. Declaration and initialization separately, you can do it, but if you're doing initialization separately, if you try to initialize like this will not work. Why? I just showed you. Even for integers, when you declare like this, it is fine, int a of 20. But if you try to initialize like this, where a equal to all the list of numbers, it will not work. If you are giving the entire list of numbers in one line, then you have to either combine them in the declaration statement itself, or you have to break them into multiple lines and give each index separately. Same thing is happening here. So where is that? Okay, I erased it. What I'm saying, so let's copy this. So in this case, what did we do? Declaration and initialization, we did both in the same line. Fine. Now let me separate them. I have to specify something. And then I say a equal to this. Okay, this will not work. Let's see. You see, it gave an error. You can't give the entire list in a different line. If you are giving the entire list, then you give it in the initial declaration line itself. If you separate declaration and initialization, then you can't give the entire list in initialization. You have to give element by element. Okay, but the same thing. Same issue comes here also. Whether you are giving them as separate characters or as a string, both are equivalent. It is breaking this into the same list, right? This will also not work. Error. Because it's like it's equivalent to assigning the entire list in the same line. But you're not doing it in the declaration line. You're separating it. So it will not work. So you have to combine it in the declaration line itself, then it will work. Or you give character by character. Okay. So one way is you say a of 0 is h. A of 1, a of 2, a of 3, a of 4. This is E, sorry, E, L, L, O. This will work. Okay. I hope you got the point. This will work. All right. But suppose I don't want to put so much effort. I may not know the string during declaration statement itself. I may want to change the string later, or I may want to copy one string from one to the other. Okay. Or declare initialize this string later. Every time I can't go character by character, I want to assign a string. Okay, then what to do? So to explain that, first let me tell you how copying works from one string to another. Then it is easy for you to understand how initializing a string will also work. So suppose I have two strings A and B. Say A maximum size is 10, B maximum size is 10. And suppose I already know a name. Say I want to store some person's name. Okay. Now I want to store this. I want to copy this name from A to B. Okay. So there is a function. Like I said, strings are special. Out of all the arrays, strings are special. Character arrays are special because we use them many times. So there are some functions, inbuilt functions in C, which you can use to make your life easier. So there is a function called string copy, strcpy, where you want to copy A's contents into B. So you write B comma A. So whatever you want to copy into, write that name first, and then from where you want to copy, write that name second. So this will copy the contents of A to B. All right. But to use this function, you should include a library called string.h. Fine. Now let's print both A and B. Let's say A is so and so, and B is so and so. Okay. Fine. So both should print Ramesh. All right. That's it. So I copied the contents of B to A. Here, if you notice, I did not use a statement like this. B equal to A. This will not work. This will not work. Only this will work. Okay. These are not simple variables where you can copy one variable value to another. This is not int, not char, not float. This is an array. So this is true for all arrays. You can't declare two integer arrays and then say A equal to B. That will not work. You have to copy element by element. Similarly, in strings, one way is you declare two character arrays, you copy element by element. But only for strings, you have an additional function, string copy. Yeah. Yes. Seventh itself. So 7 to 10 all are null characters. Yeah. So assignment operator will not work for arrays. Any array. Direct assignment will not work. You can't assign an entire array to another array. Okay, because you need to create space for each of these arrays, and just by declaring not only space, the space can be created, but copying will require looping, and you cannot what do we mean? This you will understand when we get into pointers, because whatever you're doing with arrays is finally translated to pointers. So what is possible with pointers, what is not possible with pointers will define what is possible with arrays, what is not possible with arrays. Okay, so simple assignment you cannot do either for character array or integer array. You can't say B equal to A if you want to copy A to B. That will not work. For strings, that is character arrays, you have functions like string copy, which will allow you to at least copy. But for integer float arrays, you don't even have such functions. Sorry? B equal to 6 will the string copy word. B of 6. Achha, B of 6. Okay, so let's. Let's see. What happened? Why did this not print? I don't know. I have to see why this is not working. This should work. I mean, at least A should be printed. So I don't know why changing B is affecting A. No, but A has null characters, right? A should be printed at least. In fact, B, if it is empty or something wrong with B, we can understand. Something was wrong with A, so that is surprising. I'll get back to you on this. Yeah. Yeah, I gave the names correctly. I don't know why. Okay, we'll see. All right. What else? So for copying, yeah. So copying we saw. Now same method can be applied to initialize an array later to separate. When you separate declaration and initialization, direct assignment operator didn't work, but string copy can be used to initialize an array separately from declaration. So suppose this, I don't want this. So here, suppose I want to initialize array to some string. I can specify that string here. So this will copy that string into A. So this is equivalent to saying A equal to Ramesh. This will not work. Only this will work. Fine. So you can't directly assign an entire array into the array variable. It can be character array, it can be integer array, whatever it is. If you're separating declaration and initialization, you can't assign entire array. But you can copy using string copy function. You can copy the value, the entire string into the array. Okay. This works. Fine. All right. So these are some examples. So now let's work out some codes. Let's this we tried. This I just showed you. So here I have a null character in between. Okay. The array size will be what? Array size will be 5 or 8. It will be 8. See, for an array, it doesn't matter what character is there. Only when you are using percentages, this character matters. Otherwise, this is like any other character. All these characters will be stored in the array. Okay. So one way is you loop through this array from 0 to 7, where all these characters are printed. When you try to print this, nothing will be printed, not even space. You will just see hello MR if you just try to loop through this. So what we will do, I less than 8, I plus plus, print percentage. What should we say? Percentage C. I'll not give a new line. And here, what should I say? A of I. When you're printing each character, you should specify A of I. But when you're printing the entire string, you just say A. Okay. Yeah. And finally, I'll print a new line for readability. See, it's printing hello MR. It's printing null character also, but there's nothing to print there. That's why. So when you run the loop, it will print. But when you use percentages, it will stop at hello. So for percentages, null character is the delimiter. That's all. So this one, you are trying to print percentages. It will stop at hello. That's it. It does not print MR. Okay. So null character is specifically important when you want to use percentages later. All right. And sorry. Suppose I want to take the string from the user. Suppose I know the user wants to give some string. Then I can scan the entire string from the user. Again, same format specifier. Percentages. Okay. Here, what should I give? No. Since you are scanning the entire array in one go, you see, if you are scanning one variable or one character or one integer, then you need to give ampersand. But if you are scanning the entire array, no need to give ampersand. Again, this you will understand when we get to pointers. Okay. Just give A. Okay. Fine. And then print entire array percentages and scan entire array percentages, only array name. Fine. It's waiting for the name, whatever. I'll just say name. It scanned it, it printed it. Okay. All right. Now, sorry. Here you can't give name \0. You can't give because you can't input null character. Null character is a special character. Every character is not a printable character. So \0 is a special character which is used by the computer to like a marker or something like that. But you can't input null character. Okay. All right. Suppose if I want to scan one character at a time, then what do we need to do? I need to remove this scanf and I need to say, suppose if I know there are only 4 characters, max 4 characters in the input string. I want to scan character by character. Then what should I say? %C and first character goes to A of 0. Now, since you are scanning one character at a time, A of 0 is like any variable. So you should put ampersand before that. So you should write ampersand A of 0. Similarly, for the remaining 3 characters, ampersand A of 1, ampersand A of 2, ampersand A of 3. Okay. Suppose I say hi. It is waiting for the remaining 2 characters. I pressed enter and again I pressed enter. So it took 2 enters as the remaining 2 characters. Okay. So any character you enter, be it the enter key or space key or whatever it is, it will take those characters. Suppose I say hi, space J, enter. It will take that. Or suppose I say hi, space, enter. It will take that. Okay. That's it. I can't give \0. If I try to give \0, what will happen? Hi, \0. What will happen? Will it take \0 as the null character? No. What will it take? What are the characters that it takes here? Exactly. H, I, single quote, \. These 4 characters it will take. So the single quote becomes a character like space or enter. Stops there. Okay. Yeah. Fine. All right. Okay. So you should put ampersand if you are scanning element by element. But if you are scanning entire array, do not put ampersand. If you are putting an index number only, then you should put ampersand. If you are not putting index number, if you are putting only the array name, no ampersand. Okay. All right. So percentages will take care of that. When you press an enter, percentages will take all the characters until you press enter. So some white space character it will look for either space or actually let's see that. Suppose this is A of 10, right? Now, so here what am I doing? I'm directly using percentages to scan. Okay. So suppose I say hello and I press enter, it is taking hello. Now suppose I say hello world. Now what do you think it will take? Will it take entire 10 characters? It will take only hello. It will stop at the first white space character. So that's what. Now what if I give a large string without any white space? Now, yeah. Yeah, sort of, but it will also give an error. It will not take first 10 characters actually because it is looking for the first white space character. So white space character comes much later after 20 characters or 30 characters, but that is overflowing beyond its memory. So it will give an error. Okay. I hope you got. All right. So these are some things with practice, you will understand what will happen in each case. That's all. It's not something to memorize. The more you practice, the more it will be clear to you. Okay. That's what happened here. No, I pressed an enter. Enter is a white space character. Yeah. Same thing. Like we can say this and then space and then whatever. Same thing. Yeah. Okay. So this is slightly different example here. So here the array size is very small. I am assigning a larger string to the array in the code itself. In the previous case, I was scanning it from the user. Now I am assigning a larger string to the array in the code itself. Okay. In this case, it will not give an error. It will truncate the string and take the first 3 characters. Technically, what should happen? It should keep one space for the null character and take only the first 2 visible characters from the string. Because the array size is 3, one space should be reserved for the null character and 2 visible characters should come. So only HE and null character should be stored in the array. So when you do percentages, it should print only HE. But you see what it will print. It's only warning, it's not an error. It's just saying the string size is large. It is taking HEL. It is taking the 3 visible characters, and in the 4th space, which is outside the array, it is storing the null character. So technically, that should not, I mean, technically it is happening, but ideally that is wrong. It is accessing the cell outside the array. You can even print, just a minute. No, yeah, here you can even print the values, decimal values. So like I said, 3 characters only should be stored, which means 2 visible characters and 1 null character should be stored. Only HE should be stored, but it is storing HEL, and in the 4th space, which is outside the array, it is storing the null character. So we can print that and see. So we can run the loop. I less than 4, which means 0 to 3, which means it will go to the 4th character and print the characters A of I. Okay. See, HEL and null character. Suppose I print their decimal values. ASCII values of H, E, L and null character. So no matter how many times you print it, this null character will not change because it is actually storing the null character there. That is not good because it is storing it in the out of bound location. It should stop at index 2, but it is going up to index 3. It is going to the 4th element, which is outside the array. But that is a problem in C. But that is something which is happening. Okay, you need to keep that in mind. But suppose if I go beyond this, what if I go up to say, 10? Okay, it is printing some random ASCII values. All right, these ASCII values will change. The first 4, that is H, E, L and the null character, they will remain the same. The remaining ASCII values will keep changing. Right? Why? Because you see, array is stored somewhere in the RAM. The remaining cells, we don't know which process is using, which other application is using. That may be constantly be getting updated. Some process may be running in that and that is getting updated. That is one possibility. Another possibility is every time you're running the code, it's not necessary that your array is getting created and stored in the same exact location in the RAM. Sometimes it is getting stored at address 100. Sometimes it is getting stored at address 250. Some other time it is getting stored at address 100352, something like that. So your array is being created and destroyed and being recreated at a different location each time. So what are the contents of those neighboring cells? We don't know. So this keeps changing every time. All right. So you see these lower values are constantly changing. Okay. So those are garbage values. We don't know what is there in that cell. Fine. All right. Yes, that is what is happening. It is already accessing that cell. Something was there in every cell, something or will be there. So when this memory is reserved to an array, it overrides those contents, right? It's not like RAM is all empty and waiting for the array to come. Some information or data will be there. Yeah, this sort of thing we saw. The character, no, this, yeah, this we should see. This we saw actually. We just saw this, right? In one of the earlier codes. Yeah. No. Yeah, this is this one. In this case, it's a of 3. In this case, I just gave a of 10. We can always give larger than 10. Same result will come. Okay. So I won't run this again. Yeah, we can try this. So here, what are we doing? You see, in all the previous cases, we were running the loop from particular index to particular index. In this case, we are not taking the end index. We don't know exactly. What we are looking for is, we are looking for the marker. We are looking for the null character. That we are specifying as the terminating condition in the loop. So you start from 0 and go until you find the null character. Keep going and keep printing that character. Okay. So the terminating condition always need not be in terms of plain I. It can be any truth statement. It is a function of I, but it is a slightly complex function. It's not direct I. So you are checking for a truth statement until A of I is not a null character. Keep printing. The moment you find A of I to be null character, stop. Don't enter the loop. Get out. So it will print all the characters before the null character. Okay. So, and here you see the printf thing also. It is a slightly complex thing, but it is for more readability. I want to print A of 0 is this, A of 1 is this, A of 2 is this. So the inner number, index number is getting updated. And that is nothing but the value of I. So I put %d here. Okay. And then what is the value of that? That is %c. That is A of I itself. I is the index number. A of I is the value at that index. Okay. So let's see. It stopped because it stored null character in the 4th position. Okay, at index 3. Now, same thing. Instead of %c, we give %d. Instead of printing these characters, it will print their ASCII values. Okay, so I'll change it here itself. So instead of %c here, I will give %d. So the ASCII values of each of those characters. HEL, that is printed. Okay. And then let's try this one. I need just 5 more minutes. I'll because you need to be on par with the other section. Sorry. So here, what are we doing? First of all, the array size is less than the string size. So HEL will be stored, and then null character will be stored, and then you're going beyond the array limits. Garbage values should be printed. Okay. You see, HEL, and then 4th one is null character. After that, these are all garbage values. And some of these garbage values, some of these numbers may be maybe within the range of ASCII. What is ASCII range or extended ASCII range? 0 to 255. So if the number falls within 0 to 255, it will try to convert it to character and print that character. But if that number is a negative number, or if it goes beyond 255, there is no visible mapping to a character. So it will print these kind of question marks. Okay. So these numbers need not fall within 0 to 255 range, right? It can be any number, right? So if we run it again and again, these ASCII values are changing. Okay. Now among these, you see here for all of them, A of 3, A of 4, A of 5 is printed, but here A is not printed. Any idea what is happening? In all these cases, A is printed, right? But here, why is A not printed? because one of the values there, ASCII value there or the character there is backspace character. It deleted that A. It printed and deleted that A. Okay. So even in C, you can print backspace. You can print something and delete it using backspace. Okay. So let's just quickly see that. Suppose I have A of 5, A of 6 equal to hello. I'll first normally print hello and what do we say? Okay, this you all know, it will just print hello, right? Now I'll print a backspace character. So how do you print backspace in C? It is \B. All right. Okay, just a minute. Okay, okay, this will not work. So I should not put backspace, and because when you press an enter key, and even if you put backspace, it will stay in the same line. It will not go to the previous line and delete, right? So you should, backspace is useful if you are deleting in the same line. All right. So I will not put a new line in the previous line. So now if I say backspace, you see O is gone. All right. So this is useful. Now another thing is, suppose if I want to, you see one of the problems which we discussed earlier, counting the number of digits in a number. You remember the problem? I give a number, the user gives a number. It can be 3-digit number, 5-digit number, 10-digit number. I want my code to count the number of digits and print that number. Okay. So how did we do that? We used a loop, and in the loop, we divided the number by 10 each time. So it is kicking out a character. At the same time, we are incrementing the count by 1. So the number of times it enters the loop, those many count is increased by those many times. So that gives me the count of digits. But a simpler method without using loop, also this can be done. Any ideas? Some very basic command. I mean, very basic thing which you learned. No, not size of. The very first command which you learned in lab, what is that? Yeah, what value will it return? Exactly. We can just use printf. We can print that number once onto the screen, and printf will return a value. What will be the value returned by printf? Number of characters it printed, which means when you print this number, the number of digits in this number will be the number of characters. So it will return that value. You store that value in some other variable and then print that variable. Okay. So it's not char. Suppose I say int n, the number which the user will give, and count is the number of digits, or let's say digits. So first I scan this number from the user, and then I print this number, and I will store this value in digits. Okay. Or let me say count. Count is more intuitive. Okay. So now I will print count. All right. So once you printed that number which the user gave, those many digits are printed onto the screen, which means those many characters are printed onto the screen. So whatever are those number of characters, that will be stored in count. So count is the answer. So you need not use a loop to count the number of digits, right? So let's quickly run this. Some number, say 3-digit number. You see, it printed that number and the number of digits. Suppose some 6-digit number. It printed that number and the count. But this is fine. But suppose if this problem is asked in Euclid, then and in Euclid you are asked to print only the count. In this method, you necessarily have to print the number also. So number and the count are being printed in your code, but I want only the count. Then what to do? If you print both number and the count, your code will be rejected. You should print only the count because the output should match exactly, right? So in that case, what we will do, we will print the number and then clear the screen. And only count we will print after clearing the screen. So only count will be visible. Okay. So to clear the screen, there is a command, not this, system clear. And to use this command, you should include a library called stdlib.h. Okay. Fine. Now let's see. Okay, so what is happening is it is clearing the screen, but then whatever is already printed, it is not erasing that. It is not that it printed it again. So what we will do, we will put a new line here after the number. Then it will clear all the previous lines. Okay, currently it did not clear the number because the current line it is not clearing. It comes back to that line. But I want this to go back to the previous line so that the number is in the previous line and the current line there is nothing. That's why I'm printing a new line. Then it will clear all the previous lines, n-1 lines. Okay. Yes, I'll come there. So actually there were 5 digits in the number I gave, but it is printing 6. Why? Because new line also it is taking as a digit. So instead of saying count, we will say print count -1. This will give me the exact number of digits in the number. So suppose this has 5 digits, it prints 5. Okay. Suppose this has 7 digits, it prints 7. Okay. So now only the count is printed. You're not using loop. You're just using printf. Only the count is being printed. You're not printing the number. Okay. So these are some things which, so these are system functions basically. You see, I don't know whether you're noticing whenever I am running, I'm doing something so that the screen is actually being cleared. Every time I do ./out, I'm clearing the screen and I'm doing it. So this is a system function. The same system functions can be put inside the code. So system clear, actually what is happening, clear is the command which clears the screen. The same command I'm putting in the code by using the system command. So clear means it asks the system to run this command. So it is clearing the screen. That is what is happening. Okay. I am not typing clear every time because I have a shortcut for that. You're not seeing that, but I am actually running clear command. Okay. So that's why C is more system programming language. Many of the system functions you can incorporate in C. Okay. And this is another example where the concepts which we discussed earlier, why printf, you see, when you understand the depth of printf, that printf will also return something. Why? Because it is an expression statement. So out of the different kinds of statements we discussed, expression statements always return a value. If you remember that, and if you remember printf is a kind of expression statement, then you will get this idea that I can use printf to solve this problem rather than running loop and then dividing number and then incrementing count, all these things. It's more complicated, right? So this kind of thinking is possible only if you try to link your theory with your programming. So don't think theory is just for theory. That will help you to think in lateral ways. Okay, so that's the idea. All right, so let's stop here.